Hello everyone, welcome to the live class. So guys, today we are having another session which is about the contour integration, and in this session we are going to continue the discussion about the contour integration which we were discussing. Before this session also we already had two sessions about the contour integration. So I hope that you all have watched those two sessions, but if you have not attended the sessions, if you have not watched the recordings, you can watch those two sessions as well, because then you will be able to know about each and everything which I have discussed in those two sessions regarding the contour integration topic. Clear? And at any point of time, if you will have any doubt, you can even let me know about that during the sessions. Clear? Also guys, let's start the discussion about the questions which we are going to discuss today. But before that, I am going to let you know about the Unacademy Plus subscription and the benefits of taking the Unacademy Plus subscription. So each and every important point and the discussion regarding the contour integration based conditions, tricks and many important questions we will continue. But before that, let's talk about the Unacademy Plus subscription and its benefits. So guys, I hope that most of you already know about the Unacademy Plus subscription and the benefits of taking the Unacademy Plus subscription. So if you want to take the Unacademy Plus subscription, you can take the subscription, and to get the 10% discount in the total subscription amount, you can use the referral code Anjali Arora. It's like you can now use it Anjali A Live. Okay. So you can also use this referral code, that is Anjali A Live, which I have mentioned here. Okay, so this referral code you can use, you can apply it and get the 10% discount in the total subscription amount. Now, what are the benefits of getting the Unacademy Plus subscription? So guys, well structured is this one as well. Okay, so well structured and the well planned courses will be there, weekly quizzes will be there, doubt clearing sessions will be there, mock tests will be there, PDF of important notes will be available to you, recordings of the live classes will also be available to you, and once when you will take the subscription, you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your exam preparation. Okay. Also guys, if I'm going to talk about the other what are the courses going on Unacademy Plus for your exam preparation, so these are the courses which are going to start in January. Okay, so capsule course on physics with practice questions, this one is the one course. Then complete course on core topics of physics for June 2020. Then crash course on physics with previous year questions. Then Excel for physical sciences, complete course on physical sciences, complete course on electronics and thermodynamics, course on advanced level quantum mechanics, complete course on classical and mathematical physics, and capsule course on differential equations. These are the Unacademy Plus courses going on Unacademy Plus, and some will start soon. Like this is the Excel course which will start on 6th January. Okay, and there are many other courses which will start soon in January now. Okay, the other important information also I have provided you here. And guys, whenever you will use the referral code and when you will apply it, at the same time you will get the 10% discount in the total subscription amount. Okay. Now, there are many special classes which we will conduct in January. Okay, so these special classes will be on these dates like 8th January, then 9th, then 10th, 15th, 16th, 17th, 20th, 21st, 22nd, 27th and 28th January. So these are the special classes which we will have in January at 10 AM in the morning. Clear? Also guys, on 8th, 9th and 10th January, we will have the live sessions on this channel, that is Unacademy Live CSIR UGC Net at 8:30 AM. So before these special classes on these same dates, okay, you will have the live class on this channel as well, which is Unacademy Live CSIR UGC Net. So here also in the morning at 8:30 we will have the live classes on 8th January, 9th and 10th, then 15th, 16th and 17th, and the timing of the live sessions here will be 8:30 AM. Okay, and the topics are different on this channel, and for the special classes topics are different. And if you want to attend these special classes, you can do the registration for the classes, which will be the free registration. Okay. Now guys, in our previous classes of contour integration, we have discussed so many important things regarding the contour integration. Okay, I hope that each and everything will be clear to everyone. But still, if you are having any doubt at any point, you can let me know about it. So all this discussion I have already done in the previous classes. If you have not attended that, you can watch the recordings of those classes. That will be helpful for you. Clear? And at any point of time, if you will have any doubt, you can even tell me about those doubts. Now, let's continue the discussion and let's talk about other conditions and other important types of question. So guys, here I have discussed this question in our previous class. Okay, the detailed method and the trick as well. So what was the trick? The trick was, if you are having, I think it's mentioned here as well. See, this was the trick. Integration from 0 to infinity dx upon 1 plus x to the power n, that will be equal to pi by n cosec pi by n when n is greater than 1. Okay, and the limits of integration, you need to focus on this thing. So we have already done the detailed discussion about this trick in our previous session. Clear? Now, here we are having the detailed method of solving this question. This question has been asked in the NET June 2015 exam. So similarly, you may expect this kind of question in your upcoming exams. And let's say if the limits of integration which are given to you are from minus infinity to plus infinity, okay, as it is given here, then what do you need to do? In that case, you will use this detailed method which I have mentioned here, okay, like all these steps. And by using these detailed method, okay, you can find the answer for any kind of question in which the format of this type will be given to you. Clear? So I hope that now it's going to be easy for you to solve this question, because we have discussed it in detail in our previous session. The name of the session is New Year Resolution. Okay, so you can check that session if you have not watched it. Now, let's talk about our next question. So guys, this is our next question which we are going to discuss in today's session now. Okay, so this question has been asked in the NET June 2016 exam. The question is 1 upon 2 pi iota integration over the closed contour, okay, e to the power 4z minus 1 upon cos hyperbolic z minus 2 sin hyperbolic z dz around the unit circle C traversed in the anti-clockwise direction is. So you need to find this integration. Now the point is, see guys, right now when you are looking at this question, when you are going to get it, I have also mentioned the answer below the question. But the point is, you should not directly move to the answer. Okay, you should not directly consider that, okay, this is the answer, I just need to look at the answer directly. No. Okay, if you are doing the questions in this manner, that is not the correct way of solving the questions. Now, okay, if it is not correct way, then what is the correct method of solving the questions? Let me just tell you about it. Very good evening, Ujjwal. Now, guys, if I am going to talk about the correct method or the correct way of solving this kind of question, that is, when we are getting the question, initially we should try to think, we should try to do it, that okay, what will be the correct or the exact steps I can take to solve it. Okay, so if you will think it in this way, you will get many ideas. You will get to know about it, whether you can work on this kind of question or not. Okay, instead of just looking at the direct steps which you need to take to solve the question, which have already been mentioned here, if you will do it in this manner, that initially you are going to read the question, then you are trying to relate the concepts, you are trying to get to know about the points which you can use to solve this question. So do it step by step, and whenever you are practicing the questions, consider like you are doing it in the exam. Okay, because then you will relate the things in the exactly same manner as you do in the examination hall. So which is the best way of practicing the questions and even of solving the previous year questions. Clear? Now, so that's the first thing. Okay, so when I'm reading this question, I'm getting it for the first time, what I will do, what I will think about it. See, here is the cos hyperbolic, here is the sin hyperbolic. So guys, we all know that we can write the cos hyperbolic and the sin hyperbolic in terms of exponential functions. Okay, to make it simple, to get the simplified expression for this one, what I will do, I will try to convert the cos hyperbolic and the sin hyperbolic in terms of exponentials. Okay, and for that we should know about the exponential expressions of cos hyperbolic and sine hyperbolic. So if you already know about it, this is for the cos hyperbolic z and this is for the sine hyperbolic z if I will write 2 in the denominator. Now it is for sine. Since 2 is already present here, I am going to write 2, clear? So just cancel it and then you will get normally which was already present, clear? So just to do the simplification, I have done this thing that I have put the value of cos hyperbolic and sine hyperbolic, clear? And this step will make the expression more simple and make this question easy for you to solve. So once you have put the values of cos hyperbolic and sine hyperbolic, this is what you are getting. After this, let's take the LCM and let's try to simplify the things more. So when I am going to take the LCM, when I am going to simplify it, I am getting this FZ, clear? Now, what is our next step? Till this point, we have just done the simplification steps for the given function. After this step, guys, what we will do? After this, we will just follow the normal, the general, the basic steps of solving any question of contour integration. Okay, so what are these steps? Step 1 is find the poles. To find the poles, what you need to do? You just need to equate the denominator with 0 and from there, whatever values you are getting, that represents the pole. Okay, the values of z. Very good evening, Mohammed. I'm good. How are you? Okay, now, so here we are going to have this expression that is 3 e to the power minus z minus e to the power z is equal to 0. Clear? So when you are going to simplify it, what you will get? You can either take it on the other side, then just do the cross multiplication and try to simplify that. You will get the expression e to the power 2z is equal to 3. Now guys, you can observe one thing, that when I have removed this exponential from this side, okay, then I will take the log on the other side. So it will become 2z is equal to log 3. Okay, or even if I am going to write it in this way, then I will get z is equal to 1 upon 2 log 3. If you will do it in this simple, like by following these simple steps or in this simple manner, then also you will get the correct answer. But I have also added something here, that is, like you can see, I have taken some different steps. So along with 3 I have considered 1 is also present. Then for the 1 I have taken this exponential term here, that is, if plus 1 is there, I can write it in the form of exponential, that is e to the power iota 2n pi. Okay, and 3 if I want to write, I can write it in terms of exponential like this, e to the power log 3, because log base is also e. Okay, so e to the power log e3, that will show us just 3. Okay, so that is also showing the same thing which is already present here. So there is no difference in the expression which I have written here or in 3. Clear? So that is also showing 3 but in a little different manner. Now the point is this going to affect our answer in any way? Right now it may not affect your answer, but sometimes if the answer will be given to you in the form of exponential or with this kind of term, then you may need it. Okay, so you should have an idea that sometimes you may also have to include these points when you are writing some expression, but right now it will not affect anything if you are not even going to consider this part. Clear? But if you are considering, you are working like very carefully for this question, you will not make mistake anywhere. So that's a good part. Okay, you can consider it and you can follow these steps which we are following right now. But even if you are finding ki, no, I just want to do it in a very simple manner, I just directly want to find the value of z, so you will only get it this much and that's okay. Clear? Because it's not affecting anything. But yeah, at this stage we all should know about it, that exponential part also we can include, and how we are including, that's all we have discussed. Clear? Now this is the value of z. What it is representing? It is just the pole. Clear? Now what is the contour given to us? The contour is around the unit circle C. Unit circle. Unit circle means what? A circle which is having a center at the origin and radius 1 units. Clear? Now if I am going to talk about this thing, will this point exist within a unit circle or not? So yeah, this will exist within a unit circle, because if you will find the value of log 3 and when you will divide it by 2, you will get one value which is less than 1. Clear? But your unit circle is a circle. If I am going to draw it here, that will be of this kind. Origin is the center of the circle and radius is 1 unit. Clear? And this value will be less than 1. So that's why it is existing within the contour, and we will find the residue at this pole or at this value of z. Now guys, if I am talking about the residue, then what is the order of this pole? What is the overall power of that term with the help of which you have got to know about this value of z? So that is 1. Okay, so overall power is 1. That is showing the order of this pole is 1. Clear? Now order is 1. After this, what we will do? After this guys, we will use the formula to find the residue for the simple pole. Clear? As I have told you in the previous session, okay, which was about the contour integration, okay, so there I have told you about this thing, that whenever exponential will be involved in our question, okay, then we prefer to use the formula to find the residue, which is, if the function is like this, then residue of the function, okay, at z is equal to a pole will be equal to sine z upon phi dash z at z is equal to a. And when we can use it? Whenever the denominator's value at the pole is 0, but the numerator's value at the pole is not equal to 0. Clear? Then you can use it. Now guys, whenever exponential will be involved in the question or in the expression, we prefer to use this formula. And here also we can see that exponential is involved in our question. Clear? So what we will prefer? We will prefer to use this formula. Okay, but as per the given question also, you can take this decision that, okay, is it fine? Is this okay if I am using this formula or not? Will it be complicated or will it be simple? So at the same time also you can take that decision, but mostly we do it in this manner. So here also what I have done to find the residue of the given function, okay, at this given pole, I have used that same formula. So you will find that when I am going to do the differentiation of the denominator, because in this formula what we need to do, just the differentiation of denominator and numerator we need to keep as it is. Okay, so when you are doing it in this manner, let's have a look at the next step. We will do the differentiation of this term and this term as well. We will get minus 3 e to the power minus z. Clear? Minus e to the power z. So you can have a look at this point. Minus 3 e to the power minus z minus e to the power z. Clear? So what I have done, I have just done the differentiation of denominator and kept the numerator as it is and just put the value of the numerator, like of z in the numerator. Clear? So when you will put the value of z in the numerator, you are going to get it e to the power 2 ln 3. How you are getting it? Because z is already in the power of exponential. Clear? So when you are going to put 1 upon 2 log 3 at the place of z, what it will become? And denominator as it is, but just put the value of z. Clear? So 2 2s are 4, it's going to be 2 log 3. So you can see the same thing I have mentioned here. And since it is 2, so you can make it 2, okay, or you can even focus on the calculation part. It's 2 here, so I should take 2 at this place as well. And in the next step, we have already made it 2, so that's okay now. Clear? Now, guys, what we are going to do next, just the simplification steps. You can see it is e to the power 2 log 3. How you can simplify it? You can take 2 which is present here as 3 to the power 2. Clear? You can even write this 2 log 3 as e to the power log 3 square. And then minus 1 upon the same thing, just do the simplification. Okay, this half power you can take here. Okay, and that will be minus half power, so it will become 1 upon root 3. So just simplification steps. Clear? After this, when you are going to simplify it more, you will get minus 8 upon root 3 as the residue of this function at this pole. Clear? Now our next step will be to find the integration, that is 2 pi iota into sum of residue at the poles which are existing within the contour. So we are getting 2 pi iota into residue. What is the residue? This. Clear? And since already in the question they have given us 1 upon 2 pi iota. So with this 1 upon 2 pi iota, this 2 pi iota will get cancelled out and you will just get minus 8 upon root 3, which is the final answer. Clear? So you can see guys, the steps were very simple and easy. But here we just need to do, I would say, a little more calculation. So calculation is involved, but rest of the things are simple. Okay. So that means when you are preparing for the exam, you have to focus on the calculation part as well. That is a very important thing which you all should include in your preparation. Okay. Now guys, I am going to give you some time. If you are having any doubt at any point, you can ask about it. You can just let me know about your doubt. Then I will try to clear it. Okay. And if everything is clear, we will start the discussion about the next type of question. Okay. So let me know if everything is clear or if there is any doubt. And you can see whenever you do some questions, whether they are from previous years or you are doing some practice questions, get the ideas from the question. Don't just consider that question as just one question you are doing. No. When you are doing one question, you are learning so many things. Okay. So try to relate it with all the things, whether it's calculation involved, whether it's about the steps you have taken. So everything. Okay. Now, let me know if there is any doubt anybody is having. Clear? Everything is clear to everyone. And see the points which we are including in the discussion, that is, if we are having the exponential involved in the question, okay, or in the expression of the function given to us, we prefer to use this formula of residue, okay, because it makes the things easy for us. Clear? So these are the little points which we learn when we do the questions, and when we are going to learn these points clearly, we will be able to use them in the other questions as well. Very good, Sharda. Now let's talk about the next one. So guys, here is our next question, which is from the GATE 2012 exam. Okay, in the previous sessions I have mainly talked about the steps, okay, the formulae and some of the questions. So before this session already we have conducted 2 sessions of contour integration. If here is someone like who has missed those 2 sessions, you can watch the recordings guys. Okay, so first session is Excel contour integration, that is the name of the session. The second one is related to New Year. Okay, so that New Year session is not only about the New Year, there also I have discussed the contour integration. Clear? So you can even check that session if you have missed, and you will got to know about all the formulae. Okay, so these sessions are in continuation. Now after today's session at 8:30 AM on 8th January, we will have our next session of contour integration, in which we will discuss other important points of contour integration on 8th January at 8:30 AM. Clear? Now guys, let's talk about this question. Have a look at this. See, initially as I've told you, don't go for the answer steps directly. Think about the things, try to relate the concept with the given question, and then decide what are the steps you will take, how you will solve it, and decide everything related to the question. So right now the question is, the value of the integral, that is integration over the closed contour C, okay, e to the power 1 upon z dz using the contour C of circle with unit radius, that is mod z is equal to 1 is, okay. So the value of the integration over the closed contour C e to the power 1 upon z dz using the contour C of the circle with unit radius is. So guys, first of all, what are the things we know about the contour integration? So we know different formula to find the residue, but we will talk about the residue later on. Before that, our first step to solve any question of contour integration is to find the poles. Clear? So the point is, can I find the pole directly? with this exponential function itself, or should I write the exponential series first and then I should try to find the pole? Clear? So you can do it in any of the manners like which I have told you, either directly or just by writing the series expansion of exponential function, and then you can decide the pole. So both the methods are correct. Okay, whichever you find more convenient, whichever you find like, yeah, it provides you more correct answer, you can use that one. Done. So our first step is to find the pole. So to find the pole, if I will consider the finite value of z which I can put here, which will make this function infinity, what is that value of z? That will be z is equal to 0. Okay. So z is equal to 0. It's going to be integration over c e to the power 1 upon 0 dz, which is integration over c e to the power infinity. What will be the value of e to the power infinity? That is infinity. Okay. So again, you can see it is also telling you that z is equal to 0 is giving you the pole. Okay. Or this is the pole which is existing here. Clear? So from here also you have got to know about the pole, and that's how you can do directly. But if you want to do it by writing the series expansion of exponential, that also you can do. So it's going to be 1 plus 1 upon z plus 1 upon factorial 2, 1 upon z square plus so on 2. Now here in this series expansion, if you will observe, then also you can find this. If you will even consider any z is equal to 0, then also it's going to be infinity. Clear? So if one term, one single term is going to become infinity and you are going to add anything in that, it will remain infinity. So what is the pole? Pole is z is equal to 0. Now we have got to know about the pole. Is there any other point which is existing, which is the finite value of z, which will make this function infinity? Is there any such kind of value of z existing? I think no. But if you are getting any value, you can tell me about it. Any finite value of z which can make this given function infinity, if it is there, you will also consider that as a pole. But here it's only z is equal to 0. In this case, what will happen? Now, I am having different methods to find the residue. But again, before talking about the residue, it's important that I should consider the fact whether this pole is existing within the contour or not. So what is the contour in this case? The contour is this. Okay, what it is representing? It is a circle with a unit radius and whose center will be at the origin, because mod z is equal to 1. And we know to find the center, z is 0. We will talk about this one. Z is equal to 0 is telling us about the center of the circle, and 1 is telling us about the radius of the circle. So it is a circle having the center at the origin and radius 1 units. Okay, so if I will draw it, I can draw it in this manner. Now, the pole which I have got, that was z is equal to 0. Is that pole existing within this contour? Yes, that is existing within the contour, that will be at the origin. That means I have to find the residue for this pole. So if I need to find the residue, now I have to select the method which I can use to find the residue for this pole. What kind of pole it is? See, from here if you will observe, you can even consider it like a simple pole, because even for this it's going to give you the infinite value, okay, when the power of z is 1. So you can consider it as a simple pole. And most of the times when we are having different powers of z existing in this manner, okay, so there we use the formula to find the residue, which is this formula. If z is equal to a is a pole, if it is a simple pole or order n pole, then also we can use this method to find the residue. Okay, so it is applicable for simple pole as well as order n pole, both. Okay, what are the steps to find the residue as per this pole? That is z minus a is equal to t. Then find the coefficient of 1 upon t. Okay, and whatever coefficient you got for 1 upon t, that's going to be the residue of the function at z is equal to a pole. Clear? So guys, now what was our pole in this question? That was 0. So z is equal to 0 is the pole. What we will do as per this method? z minus 0 is equal to t. This is our step 1. We have considered it. It is showing z is equal to t. That means if I want to know about the residue for z is equal to 0 pole, I just need to check the coefficient of 1 upon t, or even I can say 1 upon z, because in this case z and t are equal to each other. So what is the coefficient of 1 upon z? That's 1. So which is showing the residue. Okay. So finally the answer is integration is equal to 2 pi iota into sum of residue, which is going to be 2 pi iota into 1, because residue is 1, and the answer is 2 pi iota. Okay guys, now the point is, next time whenever you are going to do this question, you will do it very quickly. Right now I have taken some time to discuss it, to discuss each and every step, each and everything, why we are doing it in this manner, why we are taking this step, okay, and all the things, because I want to make it clear to you that you should have the idea that okay, what are the other possibilities, okay. But whenever you are having any confusion of this kind, that okay, what I should consider, order 1 pole, order 2 pole, or what kind of pole, then this method is better and you can go for it, whether the pole is simple or order n. This is applicable for both the situations, okay, the method which I have discussed with you just now. So go for this method and use it in this manner. Clear? I hope that now it will be clear to everyone. But still, if you are having any doubt, you want to ask anything regarding this discussion, this question, you can let me know about it and I will discuss that point. So I'm just going to give you some time so that if you want to ask anything, you can, and then we are going to start the discussion about our next question, which is this one, okay, which is related to the open contour. So I will talk about it, but before that you are having some time if you want to ask anything regarding like the discussion. In the discussion, if you are having any doubt, any point, if there is like which you want to clear. Done? Clear? Everything is clear to everyone? Okay, that's very good, Arun. Now let's talk about our next question. Okay, so guys, this is again from the previous year CSIR net exam. This question has been asked in the exam in 2018. Clear? Now let's talk about it and let's try to consider the fact that if we are having any question of this kind which is related to open contour, then what steps we take, how we solve it. Okay, so let's talk about it now. Now the question is, the integral I is equal to integration over c e to the power z dz is evaluated from the point minus 1 comma 0 to 1 comma 0 along the contour c, which is an arc of the parabola y is equal to x square minus 1 as shown in the figure. The value of I is. Okay, so guys, the question is, let's focus on the question once more and let's try to get each and everything which is mentioned in this question. Clear? See, the integral I, this is the integration which we want to find, which we have to find in this question. Clear? Is evaluated from the point minus 1 comma 0 to 1 comma 0. So from the point minus 1 comma 0 to 1 comma 0, you can see the direction which is already shown in the given figure. Clear? And they have also mentioned the point here that along the contour C, they are not saying that move from this point to this point from this path. No, they are saying along the contour C. That means they want us to find it along this path. Clear? Now next, after this they have mentioned which is an arc of the parabola y is equal to x square minus 1. Now in this question, this information is just the additional information they have given. Already when they have provided you the figure, so that figure is showing you that it is a parabola. Clear? But they have still mentioned it. So you don't need to worry about this part because it is just the information about the figure. Clear? Now next, the value of the integration, this integration is. So guys, how we will solve this kind of question? The Cauchy's residue theorem, which we already know, that theorem is only applicable for the closed contour. But here they are saying that, okay, find this integration over this path C. Okay, they are not asking us to include that real axis or anything. Then how we will do it? It's not the open contour right here. It's just the, it is just the open contour. It is not a closed contour. Okay, so to make it close, what I have to do? I have to consider this path as well. Clear? So what I will do to solve this question initially when I want to start solving it, because I am just having the information about the closed contour. Okay, that is the Cauchy's residue theorem. Okay, so I am starting it by considering it as a closed contour, in which I will consider this complete path as well as this path. Clear? Now, the point is, when we want to find this integration over the closed contour, okay, e to the power z dz, the function will remain same. This I can write in two parts. But before writing it into two parts, I am also going to talk about the pole, which is the basic method. Okay, and as per the Cauchy's residue theorem, the answer will be, or this integration over the closed contour will be 2 pi iota into sum of residue at the poles which are lying within the contour. So guys, what are the poles existing within the contour? Is there any finite value of z which you know or which you are getting which will make this function infinity? Is there any such value of z existing? I think no. Okay, it's just the infinite. When you will put z is equal to infinite, then it will become infinity. Otherwise, there is no finite value of z which will make this function infinity. That means no pole. Okay, because there is no finite value of z which can make it infinity. That means no pole. No pole means, when no pole, no residue. Clear? No pole, no residue. Then that means this residue is what? It will become 0. When it will become 0, then exactly I can say this is 0. Okay, so that means integration over the closed contour, okay, e to the power z dz will be 0, because we are not getting any pole for this given function. And when there is no pole, there will be no residue. That means residue is 0, and that means this integration is equal to 0. Done? Now, let's talk about the next point. Now, since we don't want to find this, we want to find the integration over the path C only. We don't want to find it over the closed contour. Okay, so let's talk about our main point. So how we can reach to that point? Can I write this integration into two parts? Like, one is integration over the contour C, that is this path. Clear? Plus integration from 1 to minus 1. Initially, I will follow the path which is already given in the question. That was, along this path we will move. And after that, from 1 to minus 1. Done? So, see, if you will make any changes in the limits here, that will make your answer incorrect. Okay? So, you have to be careful when you are just looking at the limits, what limits you should take. Clear? So, it's 1 to minus 1. Now, function. If I am going to talk about the function, that will remain same, e to the power z dz. Now, guys, here also I will discuss one thing with you. Since 1 to minus 1, we know that it is just the real axis. Okay, when it is the real axis, instead of writing z, you can even write e to the power x dx. But if you are someone who is saying, oh, how I can write it like directly x, how I can replace z with x. If you are not getting that point, that why I have written so, okay, the reason is because that is the real axis. Done? But still, if you are not getting it, or you want to keep it just z, clear, you can even keep it z. The reason for keeping it x or writing x was that since it is just the real axis, the real values will be there. So I have put x in place of z, but even if you will keep it as z, that's correct. Okay, and you already know this integration was equal to 0. So I have just taken it equal to 0. Now we want to find this integration. Clear? So for that reason, we have to move the other part on the other side. Just by moving it on the other side, we will get the answer for this integration easily. Now let me just show you the steps. Have a look at this. See? Integration over the closed contour, 2 pi iota into sum of residue. Residue was 0. Clear? So residue was 0 because no pole was there. So it was 0. This complete right hand side. Next, we have split this into two parts. just by making the changes in the limits of integration. Then shift it on the other side. When you will shift it on the other side, you are getting it like this. And now since I have written x, because that is just the real x is involved. If you are someone who want to keep it as z as well, you can keep it z. That will be okay. That will not make any difference in the answer. Clear? Now, yes, Arun, yeah, why we not write -1 to 1? I will talk about it once more. Clear? So, I will let you know why you can't write -1 to 1. Now, the point is, guys, just when you will solve this integration, clear, here I have just removed this negative sign by making the changes in the limits of integration. And after making these changes, we are getting it in this way. Okay, after doing the integration, after putting the limits of integration and everything, so you are getting the final answer as 2 sine hyperbolic 1, because this is showing you sine hyperbolic 1 expression. So final answer is 2 sine hyperbolic 1. Clear? In this calculation or the steps, if anybody is having any doubt, let me know. One question is already there. Arun has asked why we have not taken the limits from -1 to 1, why we have taken them from 1 to -1. I'm going to answer that once. Okay, till then, if anybody is having any doubt, you can also mention your doubt in the comments and we will discuss that point. See, Arun, you are having already this path shown in the graph or in this figure. Clear? So you can't move. Let me just tell you one more thing. See, if you are saying why we can't take the limits from -1 to 1, if you are saying you want to take the limits from -1 to 1, that means you are taking or you are considering this direction, -1 to 1. But you can see already the direction which is given in the figure, that is in this direction. So you are taking or you are considering the opposite direction in that case, which you can't do. If question has given you some information, you have to work accordingly. Clear? You can't make the changes on your own. Is that fine, Arun? Are you getting that point? So that's why this is given. Then we have to consider the direction in this way, just to like make it same as it is already given. Yes, Sakshi, I will talk about it. Hello, Sauvik. So Arun, let me know, is this clear? That you have to focus on the direction given to you. Okay, you can't change the direction on your own. If you are taking -1 to 1, that means we are changing the direction, which we can't do. We have to work according to the given question. Clear? Is that fine? Still, if you are having any doubt, you can tell me about that. Okay, now the second doubt is how we got 2 sine hyperbolic 1. Clear? Let's talk about it. See, Sakshi, let me know, is this clear till this point? Till this point, did you get it? From where I have reached to the value integration from -1 to 1 e to the power x dx. Is this clear? Because after that I will discuss. If it is clear till this point, done, that's good. See, the integration of e to the power x will be e to the power x. After doing this integration, we will just put the limits of integration. Clear? So initially we will put the upper limit. So that's going to be e to the power 1, then minus the lower limit, that is e to the power -1. Now the point is, we can also keep it as our final answer. Yes, surely we can keep it or we can consider it as our final answer. Okay. Now have a look at the options. We are getting e minus e to the power -1. Is that present in the options? No. It is e plus e to the power -1, but not e minus e to the power -1. So this is not present in the option. That means to reach to the correct answer, which will also be given in the option, I have to change the form. And how I can change the form? Then I should know about this formula. Sine hyperbolic x is equal to e to the power x minus e to the power -x upon 2. This is the formula for sine hyperbolic x. Now again the question is, how I will get to know about this thing, that I have to convert it in the form of sine hyperbolic. If you will observe the options, guys, options provide you the ideas. Okay, nobody can help you in the exam, but options can help you. Clear? So if you are observing the options, you will find, yeah, in the option sine hyperbolic is present. Then I can relate it. Then I can try to make that final answer in terms of sine hyperbolic. Because I have already got to know about this thing, that option 4 is not correct. Option 1 is not correct. Because I am getting some value which is not equal to 1 and 4 option. Done? That means any one of the rest 2 options will be correct. So how we will reach to that? This expression, these formulas should be clear to you, the basic ones. Okay, in the previous sessions which I have conducted on this channel earlier, okay, in the previous months, I have also discussed these formulae there. So if you have not watched that session, you can even watch those sessions, because in each and every session we have done the important discussion. Now guys, next point. If I want to make or convert this value in the sine hyperbolic form, what I will do for that? I have to divide it by 2, because in this formula 2 is present in the denominator. And also when I am dividing it by 2, I also have to multiply it with 2. Now what is this? What this is representing? It is representing sine hyperbolic 1, because in place of x 1 is present. So this is sine hyperbolic 1 and 2 is already multiplied. So 2 sine hyperbolic 1. Is this clear now? Sakshi, is this clear? Hello Karthi. Okay, Arun, I will talk about it. That's very good, Sakshi. Done? Yes, Souvik. See, you are getting, after putting these limits of integration, you are getting e to the power 1 minus e to the power minus 1. Done? But you know, to make it like sine hyperbolic expression, in the denominator 2 is present. Clear? So to make it or to convert it into the sine hyperbolic form, you have to divide by 2 and you have to multiply with 2 as well, because you can't just divide and you will not multiply. No, you will do the changes in such a manner that it will not affect the actual or the real expression. So we are dividing as well as we are multiplying, and now this form is becoming sine hyperbolic 1. Okay, and 2 is already in the multiplication now, so 2 sine hyperbolic 1. Is this clear, Souvik? And to everyone, guys? Done? Clear? Now, see, Arun has asked one more thing. The direction shows minus 1 to 1. Arun, that direction is not for the x values. Clear? That direction is for this path. So when you are considering this path and this separately, so you have to follow the direction which is given, but in the same manner as we are considering it. Okay, yeah, that's fine. The parabola is coming from minus 1 to 1, but along this path, it is not coming from the real axis. Okay, so when you are talking about the real axis, then it's going to be 1 to minus 1. Okay, so that's how it will become a closed curve. आपको क्या करना है? आपको इसको closed curve बनाना है ना. तो यहाँ से आप यहाँ तक पहुँच तो गए. अब इसको close कैसे करें? तो close करने के लिए हमें यहाँ से वापस जाना पड़ेगा. ठीक है, एक डायरेक्शन में हम इस पाथ के थ्रू आ गए, दूसरी डायरेक्शन में जब हमें जाना है तो हम दूसरा रास्ता लेंगे और डायरेक्शन को चेंज करेंगे, तभी क्या होगा? ये क्लोज बनेगा ऐसे. डन? आर यू गेटिंग इट नाउ? ठीक है, क्योंकि हमारा जो कोचीज रेजिड्यू थ्योरम है ना, वो क्लोज कंटूर्स के लिए होता है, और इफ यू विल जस्ट कंसीडर द पाथ अलोंग सी, दैट इज नॉट शोइंग यू द क्लोज कंटूर, दैट इज जस्ट द parabola curve or that path. Done? It's okay, Souvik. That's very good, guys. Done? Now, there is one more question which I will show you regarding or related to the open contour. So, have a look at this. This question has also been asked in the net physics previous years. Okay, so try it once. I'm giving you some time, and in that case, if you will have any doubt or if you will not get the correct answer, I will discuss it with you, but try it once. In just some time, I will also start the discussion. One more thing, when you will get the answer, let me know which one is correct according to you. Yes, Sakshi, like this is the YouTube channel which is Unacademy Live CSIR UGC Net, on which you are watching this session right now. Okay, so on this channel you can check all the sessions I have conducted till now. Okay, so all the live sessions which I will conduct, they will be available to you later on as well. You can watch them anytime. Clear? But there are like the spatial classes. I have told you about the spatial classes in the starting. Let me just tell you about that once more. Okay, now guys, just a second, I'm just going to show you that once, because that is the schedule for January, okay, for special classes, as well as I'm providing you the information about these live classes. Okay, so guys, the live classes on this channel, the next live class after today will be on 8th January. Okay, will be on 8th January at 8:30 a.m. So generally the timings of the live classes on this channel is 8:30 a.m. that is in the morning, 8:30. Okay, and the dates, on which dates I will take the live class on this channel, the dates are 8th January, 9th, 10th. Now you will say this schedule is for special classes. So this is for the special classes which we take on Unacademy. Okay, so in the Unacademy learning app, you can even join these special classes on these dates. But when we are having these special classes on the same dates, I am going to take the live class here as well at 8:30 a.m. So before this special class at 8:30 in the morning on these same dates, we will have the live class on this channel as well. Okay, so you can attend both the classes and both will be different. Like you can see here, we are taking the classes for classical mechanics, but right now on this channel I am taking the classes of mathematical physics. So special classes for January month I am taking for classical, and on YouTube channel, that is Unacademy Live CSIR UGC Net channel, I am taking the classes for mathematical physics. So in this way your both the subjects are going on. Clear? So that's how the classes will be conducted. You can attend these sessions as well as the sessions which I will conduct on this channel. Okay, and to attend these special classes you have to do the free registration. Okay, from the Unacademy learning app you can do it. Okay, now let me just show you that question, guys. Also, as I have provided you the information about this thing, that here we are having many plus courses going on Unacademy Plus. So guys, even if you want to take the Unacademy Plus subscription, you can take the subscription to attend more regular live classes, because there you will have on the regular basis more number of live classes by all the top educators. Clear? So you can take the Unacademy Plus subscription and you can attend more live classes of all these courses, because it will also be beneficial for all the students in their exam preparation. Okay, excuse me. And all these are the benefits of taking the Unacademy Plus subscription, that you get the well structured and the well planned courses. Okay, now weekly quizzes, doubt clearing sessions, recordings of the live classes will be available to you. So if any day you are going to miss any live class, you can watch the recordings. Mock tests will be available to you, PDFs will be available to you for the important notes. You will be able to attend the live classes by all the top educators on Unacademy Plus. And guys, the courses which I have shown here, all these are the courses which are going to start in January. Okay, so these courses are going to start in January. So if you want to attend the live classes of all these courses, you can take the Plus subscription. Okay, and you can attend the classes of these courses as well. Whenever you will take the subscription, you can use this referral code Anjali A Live. Okay, and you can apply it and get the 10% discount, or even if you already know about this referral code Anjali Arora, you can use like anyone. Clear? And whenever you will write the referral code and you will click on apply, at the same time you will get the 10% discount in the total subscription amount. So all these are the benefits of taking the subscription, and once you will take the subscription, you will surely get all the benefits and you will feel the improvements in your preparation. Okay, so that's going to be beneficial in all the manner. Okay, so guys, now let's continue the discussion and let me just show you that question which we were doing. And if you are having any queries, you want to ask anything about the Plus subscription and the courses, you can even message me in the Unacademy learning app. Okay, just by searching my name Anjali Arora, and there if you will have any doubt, we'll try to clear it. Okay, I will try to reply you as soon as possible. So you can even send me your doubts if you are having any query, any doubt regarding the Plus subscription, okay, or anything, then you can tell me about it. Yeah, yes, Anji, like the explanation for my classes you will get in English. Okay, the other classes which I have conducted on this channel, that I have conducted in English. Clear? So you will be able to get each and every class easily if you understand English well. Okay. you are asking for the special classes, you can do the free registration for those classes either from the Unacademy learning app. आप Unacademy learning app डाउनलोड करेंगे ना, तो वहाँ पर आप स्पेशल क्लासेस में CSIR और UGC नेट कैटेगरी में स्पेशल क्लासेस चेक कर सकते हैं, और वहाँ से आप अपने जिस एग्जाम की आप प्रिपरेशन कर रहे हैं, लाइक फिजिकल साइंस, ओके, सो फॉर फिजिकल साइंसेज द स्पेशल क्लासेस विच यू विल गेट देयर, you can do the registration from there. The registration is free and you can attend the live classes. Clear? Very good Disha, very good Savik. So basically guys, for attending those sessions registration is must. Okay, तो आपके जो sessions मिस हो गए हैं, अब आप आगे की अगर अटेंड करना चाहते हैं तो आप आगे के लिए रजिस्ट्रेशन कर लीजिए, ठीक है, क्योंकि टॉपिक्स क्या होता है, एक टॉपिक अगर हम डिस्कस कर चुके हैं, 2 कर चुके हैं, 3, मतलब जितने भी हम डिस्कस ऑलरेडी कर चुके हैं, आफ्टर दैट डिस्कशन विल बी देयर, क्लियर. सो इवन इफ यू वांट टू अटेंड रेस्ट ऑफ द क्लासेस, सो यू कैन डू द रजिस्ट्रेशन and for those classes and you can attend them. Okay, so guys, now let me just show you the steps for solving this question. Have a look at the steps once. Again, it was related to the open contour. Okay, now it was related to the open contour. Still we already know about this thing, that the Cauchy's residue theorem is only applicable for the closed contour, so we can directly use the Cauchy's residue theorem for the open contour. Here we have to make it close. Okay, so this is like the open contour given to us, around which we want to find this integration. Clear? But what we will do to solve it, we will initially consider it like a closed contour. We will also consider this path. Okay, but again, if you will observe, what are the poles you are getting? Are you getting any pole? No. Why you are not getting any pole? Because there is no finite value of z which is going to make this function infinity. You can think about the values. You will not get any finite value of z, finite, okay, which will make this function infinity. No finite value of z, so that means no pole. No pole means no residue, okay, and that means the integration over the closed contour, this complete, okay, initially I am starting with this by considering it as a closed contour. Clear? So that will be equal to 0. Why it will be 0? Because we know integration over the closed contour, see here, I think you may find it like so many things I have mentioned, but you can understand it in very easy to understandable manner. So you all know integration over the closed contour is just 2 pi iota into sum of residue. Clear? No residue, that means 0. After this, you can consider this integration as 2, like you can divide or split it into 2 parts. So it's going to be integration over the path C plus integration from -1 to +1. Clear? So it's going to be -1 to +1, because already they have given this path, but we want to make it a closed contour, so we'll consider this path after that. Done. So that's why -1 to +1, and the function will remain same, that is z square e to the power z dz, that's 0. Okay, and just make it or shift it on the other side and get the final answer. So these are the steps you need to take, guys. After this, let me just tell you one more thing. Very good, Karthi. See, before this session of contour integration, there are 2 sessions which I have already conducted on the contour integration on this channel, that is Unacademy Live CSIR UGC Net. On this same channel, I have already conducted 2 more sessions of contour integration. So I have started this topic from the basics. Okay, and this is the 3rd session of the contour integration, 3rd session. The first session name is axial contour integration. If somebody has missed that session, you can watch it. The recordings are available on this channel. Clear? The second session was named as New Year resolution. Okay, so in that session I have discussed the contour integration also. Done. So that's how you can check those 2 sessions as well, and this is our 3rd session today. So this is the part 3. Clear? This was part 1, this is part 2, and today is the part 3. After this, our next class of the contour integration on this channel will be on 8th January at 8:30 AM. Clear? So in the morning. Then on 9th January, then on 10th January. Clear? So that's how the classes have been scheduled. Okay, and most probably on these dates at 8:30 a.m. you will have the class. Very good, Vineet. Okay, and guys, here also I have shown you this. When you will do this integration, you will get 5 by e minus e after doing the integration. Clear? And this is the final answer. Done. So option C is correct in this question. You can try to do the integration in the homework if you have not done it yet. Clear? And guys, this was the discussion about like the important discussion in today's session. Now, I hope that you are getting the confidence about the contour integration topic and you know most of the things about it. So, it is a very important topic for the NET and GATE, both the exams. Okay, and guys, if you are planning to take the Unacademy Plus subscription, so you can even use the referral code Anjali A Live or the other one which I have already shared with you, Anjali Arora, anyone you can use. Clear? Apply it and get the 10% discount in the total subscription amount. Clear? And get all these benefits after taking the Unacademy Plus subscription. Clear? So after this, these are the courses which are going on by all the top educators we are having on Unacademy Plus for your exam preparation. So you can attend the live classes of all these courses and even more courses. Clear? For your exam preparation. Also guys, for part A, the classes will be available to you when you will take the Plus subscription. Part A classes which will be there, you can even attend those classes as well. Okay, so all these are the important things, all these are the important information about your preparation, about the important courses which are going on Unacademy Plus for your exam preparation. And these are the special classes in January which I will conduct on these same dates at 8:30 a.m. I will take the live class on this channel, that is Unacademy Live CSIR UGC NET. And in this month, in January month, okay, most of the classes which I will conduct on this channel, that is Unacademy Live CSIR UGC NET, will be related to mathematical physics. Like initially we are talking about contour integration, we will also talk about Dirac delta function after that, then many important topics. Clear? So if you want to prepare well for the mathematical physics, continue, like you have to attend the classes continuously, don't miss the classes. Clear? On this channel. And for classical mechanics, you can attend these special classes as well. Clear? So thank you very much everyone for joining this session today. And as I have told you about all the important courses which are going on Unacademy Plus, if you want to take the subscription, you can take the subscription because these courses are going to start in January, or some of them have started just from 1st January, some will start from 6th January. So these are January courses basically. Done. And some of the courses are like of 3 months duration or even more duration. Okay, like the Excel course or the complete course. The duration of these courses are 3 months or even more. Clear? So depending on this thing, when you will take the subscription, and if you are going to take it for 6 months, that's more better, because then you will be able to attend each and every course going on Unacademy Plus till your exam. Clear? So that's more beneficial. And even in terms of the subscription amount which you are going to pay, that's also better, like you are going to pay less amount if you will compare for the per month amount. So that's also a benefit you will get. Clear? And guys, whenever you will use the referral code, apply it and get the 10% discount in the total subscription amount. And thank you very much everyone for joining this session. Thank you.